7294. The best power mixture is that fuel/air ratio at which A. Cylinder head temperatures are the coolest. B. The most power can be obtained for any given throttle setting. C. A given power can be obtained with the highest manifold pressure or throttle setting. The correct answer is B. The fuel/air mixture plays a crucial role in determining the power output of an internal combustion engine. The optimal fuel/air ratio depends on various factors, including engine design, operating conditions, and performance requirements. The best power mixture is the fuel/air ratio at which the most power can be obtained for any given throttle setting. This is the accurate definition of the best power mixture. To achieve maximum power output, the fuel/air mixture needs to be rich enough to ensure efficient combustion and provide adequate fuel for the combustion process. A richer mixture, with a higher proportion of fuel, results in a greater amount of fuel available for combustion. This leads to more power being generated during the combustion process. However, it's important to note that there is an optimal fuel/air ratio for achieving maximum power. Going too rich or too lean beyond this optimal ratio can result in a decrease in power and efficiency. A mixture that is too rich can cause incomplete combustion, excessive fuel consumption, and increased engine wear. On the other hand, a mixture that is too lean can lead to incomplete combustion, reduced power output, and potentially damaging high temperatures. The best power mixture, therefore, strikes a balance between fuel and air to provide the maximum power output for any given throttle setting. It allows the engine to produce the greatest amount of power while maintaining efficient combustion and minimizing fuel consumption. Pilots and engine operators should refer to the aircraft's operating manual or follow specific procedures provided by the manufacturer to determine the recommended best power mixture settings for their particular engine. 7303. The basic purpose of adjusting the fuel/air mixture control at altitude is to A. Decrease the fuel flow to compensate for decreased air density. B. Decrease the amount of fuel in the mixture to compensate for increased air density. C. Increase the amount of fuel in the mixture to compensate for the decrease in pressure and density of the air. The correct answer is A. As an aircraft climbs to higher altitudes, the atmospheric pressure decreases, leading to a decrease in air density. The decrease in air density affects the amount of oxygen available for combustion in the engine. The purpose of adjusting the fuel/air mixture control at altitude is to decrease the fuel flow to compensate for decreased air density. This is the accurate explanation for adjusting the mixture control. When the air density decreases, the engine receives less air for combustion. To maintain the proper fuel/air ratio and ensure efficient combustion, the amount of fuel supplied to the engine needs to be reduced. This adjustment compensates for the reduced oxygen available due to the decreased air density. By decreasing the fuel flow, the fuel/air ratio is adjusted to a leaner mixture. A leaner mixture contains less fuel relative to the amount of air entering the engine. This adjustment helps optimize the combustion process and ensures efficient power output at higher altitudes. It's important for pilots to monitor the engine instruments and adjust the fuel/air mixture control according to the manufacturer's recommendations or specific operating procedures for their aircraft. Proper adjustment of the mixture control at altitude helps maintain engine performance, prevent excessive fuel consumption, and ensure safe operation of the aircraft. 7304. The pilot controls the air/fuel ratio with the A. Throttle. B. Manifold pressure. C. Mixture control. The correct answer is C. The air/fuel ratio refers to the proportion of air to fuel in the combustion mixture that enters the engine's cylinders. It plays a crucial role in determining the efficiency, performance, and safe operation of the engine. The pilot controls the air/fuel ratio with the mixture control. This is the accurate explanation for how the air/fuel ratio is controlled. The mixture control, also known as the fuel/air mixture control, is a control lever or knob found in the cockpit of an aircraft. It allows the pilot to adjust the ratio of fuel to air in the combustion mixture that enters the engine. By manipulating the mixture control, the pilot can either richen, increase the fuel content, or lean, decrease the fuel content, the mixture. This adjustment is necessary to ensure the proper combustion process and optimize engine performance based on the operating conditions. During different phases of flight, such as takeoff, climb, cruise, and descent, the pilot may need to adjust the mixture control to maintain the desired air/fuel ratio. For example, at higher altitudes where air density is lower, the pilot may need to lean the mixture to compensate for the reduced oxygen availability. The mixture control is typically found in piston engine aircraft, where it allows for precise control of the fuel/air ratio. In other types of engines, such as turbine engines, the air/fuel ratio may be automatically controlled by engine management systems. 7302. Unless adjusted, the fuel/air mixture becomes richer with an increase in altitude because the amount of fuel A. decreases while the volume of air decreases. B. remains constant while the volume of air decreases. C. remains constant while the density of air decreases. The correct answer is C. The fuel flow, which determines the amount of fuel entering the engine, typically remains constant unless the pilot adjusts the mixture control. However, the decrease in air density at higher altitudes means that the same amount of fuel is now being mixed with a reduced volume of air. As the volume of air decreases with altitude, the same amount of fuel is being mixed with a smaller amount of air. This results in a higher fuel-to-air ratio, meaning the mixture becomes richer. A richer mixture contains a higher proportion of fuel relative to the reduced volume of air. A richer mixture at higher altitudes compensates for the decreased air density by providing more fuel to ensure sufficient combustion. This adjustment helps maintain the proper fuel/air ratio for efficient combustion and engine performance. To optimize engine performance and prevent problems such as incomplete combustion or engine roughness, pilots need to adjust the fuel/air mixture as they climb to higher altitudes. By leaning the mixture, they can reduce the fuel flow to match the reduced air density and achieve the appropriate fuel/air ratio for the prevailing conditions. Proper adjustment of the mixture control at altitude is essential to maintain engine performance, fuel efficiency, and ensure safe operation of the aircraft. Pilots should refer to the aircraft's operating manual or follow specific procedures provided by the manufacturer for the appropriate mixture adjustments at different altitudes. 7305. At high altitudes, an excessively rich mixture will cause the A. engine to overheat. B. fouling of spark plugs. C. engine to operate smoother even though fuel consumption is increased. The correct answer is B. When the mixture is too rich, it means there is an excess amount of unburned fuel in the combustion chamber. This unburned fuel can accumulate on the spark plugs, leading to fouling. Fouling of spark plugs occurs when deposits of carbon and other combustion byproducts build upon the spark plug electrodes. These deposits can inhibit the spark plug's ability to produce a strong, consistent spark. With fouled spark plugs, the ignition of the air/fuel mixture becomes compromised. This can result in misfires, rough engine operation, reduced power output, and decreased fuel efficiency. At high altitudes, where the air density is lower, maintaining an appropriate fuel/air mixture is crucial. An excessively rich mixture not only wastes fuel, but can also lead to fouled spark plugs, which further degrade engine performance. To prevent fouling of spark plugs, pilots should lean the mixture at high altitudes. Leaning the mixture reduces the amount of fuel relative to the available air, ensuring a more appropriate fuel/air ratio for combustion. This helps prevent excessive fuel deposits on the spark plugs and promotes smoother engine operation. Proper maintenance and regular inspection of spark plugs are also essential to identify and address any fouling issues promptly. Overall, maintaining the proper fuel/air mixture is important for engine performance, efficiency, and the longevity of engine components like spark plugs. Pilots should follow manufacturer guidelines and specific operating procedures to ensure the appropriate mixture adjustments for the prevailing altitude and conditions.